Da, 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 da. Oh, hi! Welcome back to part 2 of the DuckML tutorial. In part 1, we created our AI and added a live camera view. Now we're going to finish off the app with some core ML. So, let's just do it already. Ahem. Editor, please transition. No, why aren't you doing it yet? Oh well, I'll just go. Bye. Okay, so now the next thing that we have to do, and pretty much a final thing, is just do the AI. So actually we need to do alright, so we actually need to do check if it output the our what we need. So what we're going to do is we're just going to use this use a function called capture output, which is from this delegate here. And then, so once it outputs our feed and our images, we're going to just get what we got from it. So sample buffer equals to, so it's cm sample buffer get image buffer. So now it's asking us for a sample buffer, and we can just put in sample buffer. Okay, now from there we can just now we can create a new function called scan image, and we'll need to ask for the buffer. So buffer equals to cm sam or cm image. Wait, let me check what type this is. All this AV stuff is very confusing because there's lots of long stuff, and it's not telling me. Oh, because I have not finished this. Okay, so basically, if you don't know what type it is, then you can do sample. Well, you can just do command and then click on what it is, or maybe even function itself. Or you could just go up here and then press this go to quick help using with the question mark, and Xcode is not working, and it's not giving me what it is. Oh well, I'll just have to find out what it is. Just see you in a second. Actually, it's a CV pixel buffer. So we have to write CV pixel buffer, and there we go. And then we can do scan. We can run scan image with the buffer being the sample buffer, or you could call it whatever you want. It doesn't have to be sample buffer. Okay, so now the AI. So I'm just going to get our DuckML and then just drag it straight in here, and then just use these options, and then there we go. You've created, or you've added it. Anyway, so first of all, we need to get the model. So actually before that, we need to import our core ML library. So import core ML, and then import vision. So these two is what helps us do our, well, just do the model and the AI. Okay, so after that, we can just get our model. So grab that model equals to, I think it's vn core ml model. There we go. And then we can get the DuckML. So actually, DuckML is its own class, if I can show you. Or actually, it's kind of like a function. So DuckML.model. There we go. And this throws. So again, we can just do this. Try again. And then else return. There we go. Now it should work because we, of course, have our model. And from there we can create a request and then a request handler. Those are the last two things before we can actually do that. Run our app and it's done. So let request equals to ml request. Yeah, vn caramel request, and then we'll use this one here, model and completion handler. So it asks us for our model, and then we'll just put in the model and completion handler. Just click on the this rectangle here. It's like a placeholder, and then just press enter, and then automatically creates a closure. Now, closures are basically like functions, but they're kind of functions without names. I think I covered that in a earlier video, but yeah. Now we have these parameters, so I'm just gonna delete this and put in the name. So request, and then just gonna put underscore because we don't need to get the error or anything, unless you want to print it out if there is any error. So we're going to do guard let results equals to request dot results as a I'm gonna just finish this first. There's something wrong with my autocomplete, so we'll just do vn classification observation. There we go. Finally, it works. But basically, it just takes the AI takes observations of what it says, and that's why it's an classification observation. Classification part is just seeing what, just classifying it as one of those objects that they specified. Okay, so from there we can get our most confident result, because this is an array of results. So we can handle this, or we can use this by just getting the first item, which is the most confident result. So guard let most confident result equals to results dot first, else return. Okay, now we've gotten that, the most confident result. Now we can just toy around with doing our result label stuff. So I'm just going to create a constant called confidence text, and that's going to be, so this is going to be after, or in the result label, and it's going to be after, it says, oh, it's a duck, it's an apple. So we can actually do a new line by doing backslash and n, and we can write, and then we can do some interpolation, and then put in most confident results dot confidence. Now this is going to be a number between 0 and 1, so I want to do it as a percentage, so I'm just going to multiply it by 100, and then I'm going to make it an integer because because basically it will probably just say, I don't know, 63.9856 blah blah blah, a bunch of numbers, and just gonna make it nice and neat. So I'm just gonna do it as an integer, so 93%, 95%, just that. And then after I've added a percent symbol, and I'm just gonna write confidence. Okay, from there we can actually check what the AI says about the object, what it is. So I'm just going to do a switch statement on our most confident result, the identifier. Now, the identifier is basically just what it sees, and or how it classifies it, what the object it thinks it is. Yeah, what the object is, or at least what it thinks it is. And to get the name of it, or the name of or what the identifier outputs, we can actually go to our create ML and we can see these. It actually gets the names from these folders. So if you created a name like just typed in some random letters, you might have a bit of a hard time, or maybe not, because you can copy and paste. But anyways, so I have the names here, and I'm just going to do the different cases. So case Apple, and then case Apple Watch, and make sure that the casing is correct. So case medium duck, and then case small duck. There we go. And before we do this, remember the thing about the queues and stuff? When we try to change the text of our label, we'll need to use a main thread. If not, then it won't work. So I'm just going to do dispatch queue.main.async. So this will just run this on the main thread or main queue. They're basically queue and thread. And also I'm gonna have a bit of a limiter, so like if it's at least 90% confident, then it'll work. So if most confident result dot confidence is more than 0.9, and it's going to do more than or equals, and I'm just going to put this in here. Actually, I'll put this outside because we want to have some text saying, oh, I don't know what this is. So that's what I'm doing right now. There we go, and then I'm just gonna indent it. You can use it using the command and the button, the key with the square braces or the curly braces. Whatever you call it. I mean, they're both on the key, so yeah. So actually let's just do the else statement. Like if it's not very confident, then we'll just say we're just going to go to access the result label. So result label dot text equals to I don't know what this is. Give me so I'll just say I don't know. Give me data. Give me data now, or something funny. Up to you. I mean, and okay. And you might be wondering, oh, if this doesn't use the confidence text, then why can't we put it in here? Then well, the answer is that's a good idea, and that's what I'm going to do right now. So good job on thinking ahead, because we won't need it. We'll only need it in here. So I'm just going to copy and paste this here. Actually, I'll just do the one for the apple first. So it's an apple, yummy. I'm going to eat this apple after I record, before it goes rotten. So confidence text. There we go. Now I'm just gonna copy and paste, and there we go. And I'm just going to do Apple Watch. So it's Apple Watch. So Apple Watch, don't eat, because Apple Watches are apples, but can't eat the apples. They're made of metal. Weird. This one is not made of metal though. Weird. And the computer I'm using is an apple. I just can't eat it. It's a weird conundrum, I must say. Weird conundrum. Okay, so medium duck. It's a duck. There's a duck. What else? There we go. And then the small duck, it's, whoa, tiny duck. Tiny rubber ducky. There we go. And guess I guess this is done, and now we're going to go and handle our request handler. So let request handler equals to be an image request handler. And I'm just going to do CV pixel buffer, and so CV pixel buffer, remember, it's a buffer here. So basically now it's putting the two together. So options, and then it's in a dictionary, so I'm just going to create an empty dictionary, which is 2 square braces with a colon inside it. And if you don't know what dictionary is, it's basically like a array. I'm not going to dive into it. So after that, you can do request handler dot perform, and we'll just perform our request. So here, so perform request, and you can do multiple requests because there's an array here, but we only have one request to do. Now, remember what I said about the throws? Well, here's another example of throws. Well, we have this function which throws, so we can actually do this do and catch. So this is what it looks like. So do and catch. Basically, inside this do is what the actions we shall perform that would catch. So and basically, you start to put in the try because that specifies what may not work, what function throws. And the catch is basically what happens if there's an error. But you can just print the error. It's that simple, and yeah. And you may be wondering, where does the error come from? Well, Swift automatically creates the error variable from this catch statement, and it's pretty magical. And you don't have to write. Actually, you can write a different name here, so it can be error, but that's what the earlier Swift versions used to be like. But now I can just do normal catch. There we go. And well, I'm pretty sure, well, it looks like we're done here. So why don't we just give this a shot? Well, I guess I found a problem here. So okay, first of all, we need to add a default case. And I'm just going to do return, which just says get out of this function. And from there, because we're inside a closure, like I said, well, you will need to use self. So, and there we go. Oh yes, and one more thing, or two more things. I forgot to say this, but with the AI, first of all, you can look at the size of this for mine anyway. First, it's 50 kilobytes, and well, for me, I put a few images, and well, for me, it works decently, not perfectly though. But well, for you, you should add a lot more images. A really good model would have hundreds of thousands of images, but pretty sure you don't have the time for it. So just just take about like 30, 40, 50 photos. I mean, maybe a lot, but at least 10 photos. That's the minimum. And also, more photos means it's a bigger file size. So there's this thing called quantization. I'm pretty sure I pronounced that correctly, but what it does is basically like compression, just like how YouTube's compressing this video right now. Or how it already compressed it, because, you know. So yeah, basically it compresses and makes the file size lower. It decreases file size, but there's also a trade-off. It's not going to be very accurate anymore. So you can use a bit of quantization, but too much is not good at all. So, and also, great ML, Create ML should make your file size lower. It's pretty cool. I'm not sure if it's part of Core ML or Create ML, but anyways, it just keeps the file size down. So that's a good thing to know. Okay, let's just run this and see if this works. It looks like everything's going well. Okay, so now we have our app open and it's loading. There we go. Okay, that's something we have to fix, but you can see it's a duck. What else? And then there's also let's try the rubber duck. It's a rubber ducky. Now, my model isn't very accurate, but it still works. And like I said, you have to add more photos for it to be more accurate. And here's the apple. And so you can see that when I put on the side, it's not very accurate because there's a lack of features on the apple. So it detects a stem, which is good. It just doesn't really detect the spots on it, and well, that's fine, because I mean, if it could detect the spots, I mean, anything spotty would be an apple. So anyways, what I'm just trying to say is that you just need to add more images. So more images is good, but it'll increase the file size, but quantization will decrease the file size, but it'll make your model less accurate. So let's try the Apple Watch finally. So it says Apple Watch don't eat. So just two more things. Let me just quit this app. So two more things. Well, it's not adding this confidence text here, and that seems pretty weird because it should work. Oh, actually, I remember a problem now. So remember how this was cut off before? I'm not sure if I mentioned it. I think I did, but that's both reasons. Both problems can be fixed by setting the lines on the label to 0. Doesn't mean that there will be 0 lines at all. Just means that there will be more infinite lines. So it'll put in as many lines as it can fit. So let's just run it again. If this works, we can wrap this up. Okay, so now we have our app now, and it basically says, I don't know, give me data now, and it's using 2 lines, which is great. Now the rubber ducky, there you go. Whoa, tiny rubber ducky. And then same thing, and we have a confidence here. It's a duck. What else? Oh, it's very confident. 90, and you know, if you think it just says, I don't know, give me more data now, even when you have an object in front of you. One thing, probably add more photos, but you can change the confidence limiter here, so you can change it down to 0.8, 0.5, even 0. Like, just make everything go through, and yeah. There is no minus confidence anyway, so it's just 0 to 1. Let's try the apple now. And yeah, it's an apple, yummy, very yummy. I'm just going to eat it soon after recording this video, actually. And Apple Watch don't eat. So that's good. I'm just going to quit the app, and yeah. Thank you for following this tutorial, and I hope you had a lot of fun, learned some new things, and now you have this very powerful AI in your hands, which is pretty amazing compared to since like 10 years ago. We didn't have AI at all. In fact, we didn't really have, or like 12, 13 years ago, like in the early 2000s, we didn't even have phones. So having this is very powerful.
Thanks for watching, and I hope you learned something new. To see more of what Yuma has made, go to www.madebyuma.com, and his Twitter and Instagram is @YumaSoriento. Well, goodbye. Phew, it's finally done. And now go back home. Da, 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 da.